And the workbench is now open, and you can either choose the different apps like geometry, mesh, fluent, and post-processing, or you can directly select the systems. So we have the analysis systems which are shown here. So I'm going to choose the fluent. So fluid flow with the fluent, and it contains everything: geometry, mesh, setup, solution, and results. So right click on the geometry and import geometry, and we will go to the working directory which is in the E, and it's 90 degrees bend, and the file inside is 90 degrees. So click on the file and click simply on open. Okay, and you can see few things here. Number one is that analysis type is 3D. I want to process name selection. Yes, you have to. And import coordinate system, we don't have any coordinate system, so I will not import it. I will make it my own in the meshing. Import work points and read mode save. Okay, just leave as it is. So right click here and import geometry. Click on open, and now we have to double click on the mesh to open meshing app. Because geometry is loaded, now we have to work on the meshing of this 90 degrees bend. Okay, I want to give you the rough idea about the meshing which we are going to provide. So while the geometry is opening here, let me give you idea. So for example, this length is 0.5. So if I want around 50 to 60 cells along the length, so it means that I have to divide the 0.5 by 50, and this becomes 0.5 divided by 50, this becomes 0.01. But if I want, let's say, more points, so 0.5 divided by 100, this is equal to 0.005. From my analysis, I found that the 0.002 would be the best one. So 0.002 is going to be the global size, the element size in the whole model. So what is meaning of the global size? Global size means that if you don't specify the any sizing on any part, this size will take place. Means that any unspecified sizing on any surface, this size will be used by Ansys meshing. And on the bend, we need to have the very fine mesh in this region, because the 3D flow will be here and along with the separation. So I need to provide the some sphere of influence. So maybe 2 will do the job. Okay, so one on this side and one on this side. And the sizing, I have decided here that it should be around 0.0007 for the coarse mesh. So but for the fine mesh, you can take this to maybe for medium mesh maybe 0.005, and this is for the coarse mesh, this is for the medium mesh. And for fine mesh, maybe you can try with the 0.0003. Okay, so this is for the sphere of influence. And also on this face, I'm going to say provide the same sizing 0.007 for the coarse mesh. And for inlet faces and outlet faces, I will provide the same size as the 0.007. And I'm going to provide the number of layers for the coarse mesh, inflection layers, the boundary layer which is normal to surface, 20 layers. Okay, and I want to show you the one thing here, that this is the Y plus calculator I'm going to provide with this workshop. And also in the previous workshop, I used the same calculator but different values for Reynolds number and diameter. And as you can see, Reynolds number is 60,000, diameter is 0.01. And I want to implement the Y plus as the 1, and density is 1000, viscosity is 0.001, velocity is 6. So for that case, the first cell height comes out to be the 0.5029. And if you go with the Y plus is equal to 3, this becomes the 0.5088. So let's say we go for the y plus is equal to 1. Although in my slides I mentioned the sizing to be here. The sizing of first layer height is the 0.508. This is for the y plus 3, and for y plus is equal to 1 it should be around 0.503. Okay, so and also the mesh type is tetrahedrons. So select the whole geometry and from the method choose as tetrahedrons page conforming. Okay, then the second thing is that I have to provide the sizing on the surface of the band, and the size here I want to provide is 0.0007. Okay, the next thing is that I want to provide the inflation, and that is on the 3 surfaces, 1, 2 and 3 walls. And I want to provide the first cell height myself, and this height is 0.503 for the when the y plus is equal to 1. And I want to provide the number of layers 20, and also I want to provide the sizing on the inlet, because the sizing on these surfaces will be decided automatically by our main size. But here I want to provide sizing myself. This is also 0.007. Okay, because the global sizing will take place and this will be applied on everywhere. So if I don't specify a particular size here, this will be like a point whatever I provide here. I'm going to provide here the maximum size as 0.002. So this size will be applicable anywhere where I don't specify any sizing. Okay, so this is done. Now we have to do the one more thing, that is the sphere of influence. This is basically a region of the volume where we have the refined mesh. So for that I have to specify my new coordinate system. So insert, and geometry is over here. So I will choose this face, or this edge rather. And also you can choose the one more thing, and this is now at the center of this location. Second thing you can do is that you can choose the global coordinates, and from here now you can provide the origin of x as a 0, 0, origin of y is 0.02, because now initially it was over here, so it moved to the 0.02. So let's say I move this in the x-axis by distance of 0.01. Okay, and similarly I'm going to make another coordinate system that is going to be over here. Okay, and I will move this system. So I cannot move this system basically, but I can move it by, I can choose it by the global coordinate system, and then in this case we have the minus 0.02, and I can move this in the y-axis by distance of, let's say, minus 0.01. Okay, so now we have the new 2 coordinate systems, and I'm going to define the sizing. So this is going to be the body sizing, and click on sizing. Geometry, the whole geometry, and I have to specify the sphere of influence, and the center would be at my new coordinate system, which is the first one over here. Then for second, body sizing would be here, and radius I'm going to provide is 0.02, and the size I'm going to provide is the 0.007. Okay, and similarly I can provide the second sizing here, and again the same sphere of influence, and center is going to be the coordinate system number 2, 0.01 or 0.02 maybe. Okay, and 0.007. Okay, so we have these two, and I want to merge them so that they can overlap here. So let's move these two systems by some distance. Okay, so I'm moving this by in the y-axis, and let's make it minus 0.005. And for this is going to be equal to this one. Okay, so this one would be equal to 0.0052. Okay, so now you can see that both of them are overlapping, but still we have the sum area, so we have to move them further. So I think we should make the here it should be like a 0, and similarly here it should be equal to 0. Okay, now they are overlapping. Okay, now you can click on generate mesh, and we have all these boundary conditions, and they are known as the name selections: the wall 1, wall 2, band, outlet, and the inlet. And you can see that a mesh has been computed. And the one more thing is that you must make sure that in the mesh that the physics preferences is CFD and the solvent preferences is the fluent. So now you can see that we have the very fine mesh in this region, and also we have the nice mesh over here. You can see what I learned from here, that the inflation should be around somewhere here. So in the inflation, I want to provide the growth set as maybe 1.3 and click on generate. So it should be not very close to wall, but at least it should be have the presence in the whole boundary layer. Okay, this is slightly on the higher side, so I would be choosing maybe not 1.2 or 1.3 but 1.25 and click on generate again. Okay, this seems reasonable. Okay, now click on the mesh and check the quality, and mesh metric I'm going to choose is the orthogonal quality, and it should be greater than 0.01 for the fluent. So right now the minimum quality is 0.2, which is very good. Maximum is a 0.99, so definitely the maximum would be the 1, so it's very close to 1. And the average quality is 0.85. So the majority of elements are above the 0.85 location. Okay. Second thing is that I want to take a look is the number of cells. And number of elements right now, they are around 0.8 million. Yes, 0.8 million. And in the slides, I think I have shown that I went for with the 3 meshes. The coarse mesh has the size of 0.34 million, and medium mesh has the 0.62, and the fine mesh has a size of 1.47. And why we are getting this thing? Because in the coarse mesh, I only applied the body of influence or the sphere of influence only on this part. So here it's also refined. That's why the mesh size is almost doubled by the value of the coarse mesh. This is 0.34. So now right now we have the around 0.8 million. Does not matter. So that's all. So we have the very nice mesh. And the only thing which we want to now do is that to update the mesh so that this mesh can be exported for the fluent. So simply click on the update, and you can see the message. So in any case, if there is any error, you will see the error here, and mesh translation will not be successful for the fluent. So if there is no error or the warning, the mesh will be automatically translated to the fluent. Okay, so now we can go to the next step, that is to set a problem in the fluent and solve the case.